Newton's second law of motion. Let us perform an activity to understand Newton's second law of motion. First, take a plastic ball and a rubber ball of the same shape. Ask your friend to take the balls to the terrace. Then, ask your friend to drop the plastic ball and you catch the ball. Then, ask him to drop the rubber ball and you catch it. What do you feel? Which ball was easier to catch and why? It was easier to catch the plastic ball than the rubber. Because the mass of the plastic ball is much less than that of the rubber ball. That is why, while catching the plastic ball, there was less impact on the hand. On the other hand, there was more impact on the hand while catching the rubber ball. That is why it was easier to catch the plastic ball. Now, ask your friend to stand holding the plastic ball. You stand at a particular distance in front of him. Now, ask your friend to throw the ball towards you at slow speed. Try to catch it. Now, ask your friend to throw the same ball at high speed towards you and try to catch it. What do you observe? When could you easily catch the ball? Why? The first time you could catch the ball easily as it was thrown at slow speed. When the ball was thrown at slow speed, there was less impact on our hand. On the other hand, when it was thrown at high speed, there was more impact on our hand. That is why it was easier to catch the ball that was thrown at slow speed. From this activity, we understand that the impact of the moving ball having more mass is more than the impact of the moving ball having less mass. Similarly, the impact of the ball coming with more speed is more than the impact of the ball coming with less speed. The effect of one object striking another object depends both on the mass of the former object and its velocity. This means that the effect of the force depends on a property related to both mass and velocity of the striking object. This property was termed momentum by Newton. Momentum P. Momentum is the product of mass and velocity of an object. That is, P is equal to m into v. Momentum is a vector quantity. The quantity momentum has both magnitude as well as direction. Its direction is the same as that of the velocity. In SI system, the unit of momentum is kilogram meter per second, while in CGS system it is gram centimeter per second. If an unbalanced force applied on an object causes a change in the velocity of the object, then it also causes a change in its momentum. The force necessary to cause a change in the momentum of an object depends upon the rate of change of momentum. The rate of change of momentum is proportional to the applied force, and the change of momentum occurs in the direction of the force. Suppose an object of mass m has an initial velocity u. When a force F is applied in the direction of its velocity for time t, its velocity becomes v. Therefore, the initial momentum of the object is m into u. After time t, the final momentum of the object is equal to m into v. Therefore, the rate of change of momentum equals to the change in momentum upon time. Therefore, the rate of change of momentum equals to mv minus mu upon t equals to m into v minus u upon t equals to ma. According to Newton's second law of motion, the rate of change of momentum is proportional to the applied force. Therefore, ma is proportional to F. Therefore, F is equal to kma. Here, k is the constant of proportionality and its value is 1. Therefore, F is equal to m into a. In SI system, the unit of force is Newton. The force necessary to cause an acceleration of 1 meter per second square for an object of mass 1 kilogram is called 1 Newton. 1 Newton equals to 1 kilogram into 1 meter per second square. In CGS system, the unit of force is dyne. The force necessary to cause an acceleration of 1 centimeter per second square in an object of mass 1 gram is called 1 dyne. 1 dyne equals to 1 gram into 1 centimeter per second square. Now, let us study an example. Two objects having different masses which are initially at rest are shown here. The initial momentum for both is 0. If a force F acts for time t on both the objects, then the lighter object starts moving faster than the heavier object. According to the formula F is equal to ma that we have studied earlier, the rate of change of momentum, that is F, in both the objects is the same. Therefore, F equals to mv minus mu upon t equals to m into v minus u upon t. But since the initial momentum of both the objects is 0, the total change in their momentum, that is ft, is equal to mv is also the same. Thus, the same force for the same time causes the same change in momentum for different bodies. Come, let us now answer a question. Why is there a thick bed of sand for a high jumper to fall on after his jump? When a high jumper falls on the thick bed of sand after his jump, the sand under his body slides. This increases the time taken by the high jumper to come to rest on making a jump. As a result, there is a decrease in the rate of change of momentum and hence the force on the jumper. This reduces the risk of injury to the jumper. Come, let us now study Newton's third law of motion.